angstrom. Okay, let's say the distance between carbon and carbon, the stable one is 1.5. Okay, if it's inorganic, then it's around 2 to 3 angstrom. Inorganic means like metal. Okay. So the interatomic force is determined by the gradient of the potential energy, so that F equal to negative du over dr. So if you apply this to the curve, you will see that F is negative for R larger than R naught. Okay, F is negative when R larger than R naught. You can see the change of U, okay, when R larger than R naught. Here, the change of U is positive, and then the change of R is negative, right? So the result du over dr will get negative. So this means that for large separation, the force is attractive and tending to pull the atom together. On the other word, for R smaller than R naught and F is larger than 0, when F larger than 0 means it's positive. When the force positive, that means that it pushes the atom. One atom will push the other atom. So the force will become repulsive at small separation of the atom and tend to push the atom apart. So the repulsive and attractive forces cancel each other exactly at the point R equal to R naught, which is the point of equilibrium. So we make it very simple. From this figure, when R equal to R naught, then it's equilibrium. Okay, when R larger than R naught, then the force will become negative. Okay, the force will become negative. As R is smaller than 0 means negative. Force is negative means that it is attractive force. Okay, attractive force. However, for the other region, for this region, when R is smaller than R naught, then the force will become positive. Okay, the force become positive, it means that the force now is repulsive. Okay, repulsive. In other words, you can apply this equation. Okay, so what is the difference between R and R naught, and what is the difference between U and U naught? Okay, so for this case, R is larger than R naught, right? So R is larger than R naught. So R minus R naught, you will get positive. R is larger than R naught. How about U and U naught? So U naught is much larger negative, and U is smaller negative, right? So U minus U naught, you will get negative. So the repulsive and attractive force cancel each other exactly at the point R naught, which is the point of equilibrium. And now we have 5 different types of the chemical binding that exist in solid. The attractive interatomic forces reflect the presence of bonds between atoms in solid, which are responsible for the stability of the crystal. And we know that in this world, there are a few types of the forces. We have magnetic forces, we have gravitational forces. So the 5 types of the chemical binding in the solid are: the first one is the ionic binding. Ionic binding means that the electron localized amongst atoms. The second type is the covalent binding. The covalent binding means that electrons shared by the neighboring atom. And the third type of the binding is the electron free to move through the sample, through the electron sea, and we call this type of binding metal binding. The fourth type Sometimes we call it van der Waals, and sometimes we call it molecular binding. The electrons are localized among atoms. And the last type is the hydrogen. Okay, hydrogen is a special bonding between the polarized molecule. And sometimes you get a mixture of this binding. Okay, you get a mixture. So just now I mentioned that we have 4 types of the fundamental interaction. Okay, in other words, the universe is governed by 4 forces. This is for your additional information. The first one you have studied in first year, gravity. So we know that everything that has mass will react or will interact with another thing that has mass. Okay, and we can know what is the interaction, the force between them, through the gravitational force equation. Okay, the second type of the interaction or the forces is the electromagnetic force. So this act between electrical charged particle, electricity, magnesium, and light are all produced by this force, and it also has infinite range. The third type of the force is the strong force. This force binds neutron and proton together in the core of the atom. And the last type is the weak force. This causes the beta decay, means that the conversion of the neutron to a proton and electron and an anti-neutrino. And various particles are formed by strong interaction but decay via weak interaction. So in short, we only have 4 types of the fundamental interaction in this world. And for this chapter, we are actually studying the electromagnetic force. Okay, the electromagnetic interaction. So under the electromagnetic interaction, you have chemical binding, and under chemical binding, we have 5 types of chemical binding. Okay, so this is the first one, the ionic binding. For ionic binding, the very first example is the sodium chloride. So we have been mentioning the sodium chloride, and I believe you know what is the structure of the sodium chloride. So sodium chloride is an example of the crystal with ionic binding. In this crystalline state, each sodium atom lost 1 electron to its neighboring chlorine atom. Therefore, an ionic crystal is created with positive ion and negative ion. Positive ions is referring to the sodium plus, and the negative ions is referring to chloride, Cl minus. The electrostatic interaction, the attractive and repulsive forces between these ions contribute to the ion binding. Okay, so the ionic binding is actually categorized under chemical